Hi everybody, Mrs. Danielson here, and today we're going to be talking about our complex numbers, and we're going to talk about how you change your complex numbers from polar form to rectangular form. Last time we talked about how we change our complex numbers from rectangular form to polar form. Today we're going to be doing the opposite, so just finishing up with our complex numbers. How do we get them from polar form back to rectangular form? Let's just stop by reviewing a little bit about our complex numbers. Complex numbers are of the form a plus bi. Okay. A plus bi, that's a complex number, right? It has a real part and it has an imaginary part. And in rectangular form, right, that's what it's going to look like. Rectangular form would be z equals a plus bi, a real part and an imaginary part, right? Where the real part's on the x-axis, the imaginary part's on the y-axis. In polar form, which is what we worked on in the last video, we took those numbers that were in rectangular form and we switched them and made them into polar form. So it looked like this: r times cosine plus I sine, right? Where r is our modulus and our angle is called the argument. Okay, so we were able to go from rectangular to polar, but now today we're going to work on going from polar back to rectangular, and it's actually pretty easy. It's easier than doing the opposite. To change from, let's go ahead and write this down, to change from polar form to rectangular form, we have very easy little equations to use to rectangular form. You're just going to use a is equal to r cosine and b is equal to r sine, right? Just a combination there of our modulus and our argument. Okay, so let's say we wanted to write 4 cosine 60 degrees plus I sine 60 degrees in rectangular form. And we're instructed to simplify any radicals. Okay, so that means that if there's radicals in our answer, we're going to leave them there, right? We're just going to simplify them. So no calculators on this, exact answers. Okay, so we're going to use our little equations there where a is going to be r cosine and b is r sine, where a is going to be the real part and b goes with the imaginary part. Okay, our r is 4 and our angle is 60 degrees. Okay, so we're just going to plug in what the cosine of 60 degrees is and the sine of 60 degrees. Okay, so the cosine of 60 degrees is 1/2, right? We're just going to pull that right off our unit circle. And the sine of 60 degrees is the square root of 3 over 2. And then we just simplify that. So we get for A, 2, and for B, we're going to get 2 square root of 3. Okay, so now we just plug those into our equation, and we get for the rectangular form 2 plus 2 square root of 3i, and that's it, we're done. Okay, we've changed it to rectangular form. And just kind of maybe just think about that answer for a second before you decide you're completely done, right? The original answer in polar form had an angle of 60 degrees, so that was in quadrant 1. And then just think about your answer, right? It has a positive A, it has a positive B, and a positive A and a positive B would also be in quadrant 1. So just kind of double check your answer, make sure you're in the same area, right? Does it make sense? And it does, right, before you move on. Okay, let's do another one. Let's do, let's see. Let's do one where our angles are in radians. Maybe a little bit of an angle we're not used to working with quite as much. Plus I sine 11 pi over 6. We're going to put that into rectangular form. And again, we're asked to simplify any radicals. Okay, so, not using our calculator again. If we have roots in there, we're going to leave them be. We're just going to simplify them. Maybe at this point, you want to pause the video and see if you can do this on your own. It's not too complicated. Once you find an answer, then push play again. All right, so hopefully you paused the video and found an answer. Let's see if you get the same answer we do. All right, so we're going to do A equals R cosine, and B is equal to R sine. Okay, so our modulus for this one is 7, and our angle is 11 pi over 6. Okay, so cosine 11 pi over 6 and sine 11 pi over 6, we're just going to pull off our unit circle, right? So it's going to be 7 times square root of 3 over 2, right? Just go to 11 pi over 6 on your unit circle, right? And for cosine, you pick the x value, and for sine, you pick the y value, which is -1/2. And then we're just going to simplify this. Doesn't do a whole lot, right? It's going to be 7 square root of 3 over 2, which is kind of ugly, and -7/2. Okay. So now we're just going to plug that into our format, right, for the rectangular form, which is A plus BI. So 7 square root of 3 over 2 minus 7/2 I. And that's it. Hopefully that's what you got as well, right? And you kind of think about it for a second, right? Our original angle, 11 pi over 6, that's in quadrant 4. And then our A is positive, our B is negative. Positive A, negative B would also be in quadrant 4. So just checking to make sure everything is okay, and it seems good. Okay, excellent. Okay, now not all of these problems are going to be ones where you're using your unit circle. An example of one where you would be able to grab your calculator would be one like this. Okay, one that has an angle that's not on the unit circle, right? Where we have cosine 221 plus I sine 221, right? Our argument here, the 221 degrees, that's not on your unit circle, right? So this is an example of one where we're going to have to go to our calculator. Okay, we want to write that in rectangular form. And we're going to round the real and imaginary parts to the nearest hundredth. Right, because if we're using our calculator, we have to get some decimals here. Okay, so A and B are going to be A, right, times the cosine of 221 degrees, and 8 times the sine of 221 degrees. You're going to grab your calculator, and we're going to round to the nearest hundredth. So 8 times the cosine of 221 degrees, it's going to be -6.04. And 8 times the sine of 221 degrees is -5.25. Again, I'm rounding there to the nearest hundredth, right? There's lots more decimals and digits, but we're rounding. Okay, so we put that together, A plus BI, negative 6.04 minus 5.25i. Okay, and that is that complex number in rectangular form. And again, just check to make sure you're in the right quadrant, that things look good, right? 221 degrees is in quadrant 3. And this has a negative A and a negative B, which would also be in quadrant 3. So we're in good shape. Okay, so that is how you would take a number that is in polar form and switch it back to rectangular form. Pretty easy, not a tough process. Okay, everybody have a